All right, here we go. We're going to talk about Pythagorean theorem. So Pythagorean theorem deals with key here, right triangles. So right triangles have this 90-degree angle. And the smaller sides are called the legs, and then the part that comes across is the hypotenuse. It's very obvious when they're like this, but if you orient the triangle in a different way, it's a little bit more difficult. Also, the legs come together at the right angle, but if in doubt, the longer side, as they say right here, the hypotenuse is always the longest side. So if in doubt, the hypotenuse, or C, is that. So basically what the Pythagorean theorem came up with is that the square of both legs added together is equal to the square of this length. So it's kind of interesting. So let's just jump into it and see if we can figure these out. So what we're trying to do is we're trying to use the Pythagorean theorem, excuse me, which is a squared plus b squared is equal to c squared, where we obviously have this one will be a, this will be b, and then they have c labeled for us. And it doesn't matter which one we use here, but this will be 5 squared plus 12 squared equals c squared. So we're trying to, this c squared is going to be this thing over here. And so we have 25 and we have 144, and then we add those together, and c squared is going to be equal to 144 plus 25, 169. And then this is something we're going to talk about here in a second, but a square root undoes a square. I say that again, a square root undoes a square. Therefore, taking the square root of this side and this side gets rid of this square and leaves me with c. So when you're solving an equation, you'll do this a lot in math. When you're solving an equation with squares, and you want to get rid of the square and leave c, you do the square root. So similarly, like we do the opposite operations to solve equations. So adding, we would subtract; multiplying, we would divide. If there's a square, the opposite operation is square root. So then 169 is 13 squared. And I'm just double checking myself. Yes. So C is 13. Okay, so here, what happens if our leg is missing? Well, a squared plus b squared is still equal to c squared. That's our thing. So only difference is here we're missing an a squared. And we have our b squared, which if you're unsure which one's b, it's going to be the shorter side, and since 2.1 is shorter than 2.9, well, that's it. So plus 2.1 squared is equal to 2.9 squared. And then I'm getting my calculator out here on another screen here, and that is 4. So a squared is 140 or 4.41, and that is equal to 8.41, and then we're going to subtract 4.41 from both sides, and we are going to get a squared left over, and looks like we have a 4 here because those will cancel and leave me with 4. Take the square root of both sides, and we get our a by itself, and we get a positive 2. We're going to talk about positive and negative here on the next slide. Okay, so that should get you through everything. Now we're actually going to backtrack. I wanted to go through that first, just to be different. But now we're going to talk about square roots. So this is more of the 9.1 stuff. So the radical sign is this thing, and whatever's inside the radical is called the radicand. This is just some vocabulary for you. So if we just have this, if it just says the square root of 9, then it just wants the, sorry, that's a terrible 9. I'm in a weird position here. Okay, if they just say the square root of 9, then they just want the positive square root. And the reason there's a positive square root is because, think about it, if the positive square root of 9 is 3, because 3 squared is equal to 3. Well, negative 3 squared is also 9, because two negatives is a positive, right? So we do get to, if they ask for the negative, then that would be just the negative value. But oftentimes what you'll see is this plus or minus square root symbol, and that means it wants both. So if it says plus or minus the square root of 9, then it wants us to say, well, that's plus or minus 3, right? Because positive 3 and negative 3 both get us to 9. And this gives you just 3 examples. So this would just, because this does not have the plus or minus in front of it, this is just 5. Because this does not have it, this just shows, because B just shows the negative, that would be negative 7. And because this says plus or minus, they want you to go ahead and say plus or minus 4 as your answer. So then we have a couple where we have to, then we have 2 different ones where we have to evaluate. And one of the big reasons why we did GEM-DOS instead of PEMDAS is because this first one is grouping symbols, and the square root is one of the grouping symbols. Okay, so you have to do the square root first because it is considered a grouping symbol. So we're going to multiply, we're going to do this first. We're going to bring this down, the square root of, and then we're going to add 7. The square root of 36 is just 6. And then multiply to get 30 plus 7, and then we're going to get 37. Okay, so you'll kind of have to work through those. I can help you in class. All right, so now solving an equation with we've already done that in the previous ones, but in this particular one, let's pretend like we're solving this one. Well, we're not going to pretend. We're going to solve this for a. So first thing we have to do is get rid of this 3 to get a squared by itself. 3 over 3 is 1. 48 divided by 3 is something I should know off the top of my head, but goes in there 1 time with 1 left over, which would be 16. And then we square root of both sides, and we get a is equal to 4. And in this case, I believe they may want plus or minus 4, because plus or minus 4 would, yes, they do. Because plus or minus 4 will give us the desired answer. If I plug in positive 4 to A or negative 4, I get the same thing. Anyway, so hopefully that's helpful, and fully intend on working with you guys in class. So see you there.